Hello everyone, welcome back to our channel. In this video, we'll be writing these fractions in decimal forms, and then we'll also say what kind of decimal expansion each of them have, okay? So before writing these fractions in decimal forms, I want to talk a little bit about different types of decimal expansion that we can get, okay? So there are two types of decimal expansion, okay? So one of them is terminating, and the other one is non-terminating. We say that a particular number has a terminating decimal expansion if it terminates after certain numbers, okay, or if it ends after certain numbers. So for example, if you have something like 2.78, we have this number, right? It ends after 78, right? So it terminates. Or it could be like 3.45 and 1, right? It terminates after three numbers. So if a number terminates, then that's a terminating decimal expansion. Sometimes we have numbers whose decimal expansion never terminates, which means it never ends. So we could have something like 0.3333, right? And it goes on and on and on, okay? Or we could have something like 3.141592, let's say dot, 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 dot. So it goes on and on. If a decimal expansion never ends, then that is a non-terminating decimal expansion. Now, again, in non-terminating decimal expansion, we have two different types, okay? So one of the type of non-terminating decimal expansion is a recurring non-terminating decimal expansion. And the other one is obviously non-recurring. So if you look at these two examples that I just gave of non-terminating decimal expansion, you see that in the first example, the number 3 is repeating continuously, right? Whereas in the second example, nothing is repeating, right? It just goes on and on and on. So if in a non-terminating decimal expansion, if a number or group of numbers repeat, then that is called a recurring decimal expansion. Whereas if the number does not repeat or the group of numbers never repeat, then that is called a non-recurring decimal expansion, okay? In case of recurring decimal expansion, there is another way to write the decimal expansion, okay? So for example, what we can do is instead of writing 0.333 dot dot dot, what we can just write is 0.3 and put a bar above this 3, okay? So what this means is we have 0 point, we have 3, right? And the 3 repeats continuously, okay? So if a number repeats or if a group of number repeats, then we can just put a bar instead of writing the whole string of numbers, okay? Whereas in case of non-recurring numbers, we can't do that. We have to write the numbers, right? And it never terminates, okay? Now, another thing that you need to remember is it's not always one number that repeats, okay? So sometimes there might be two numbers that keep on repeating, okay? So sometimes we might have 0.141414 and dot, dot, dot. In these cases, what we do is we write 0.14, right? And then we put a bar on both 1 and 4, okay? So both of them repeat continuously. So that's our recurring non-terminating decimal expansion. So to recap a little bit, we have our decimal expansion. There are two types of decimal expansion. One of them is terminating, the other one is non-terminating, okay? Our terminating decimal expansion ends after certain numbers, whereas the non-terminating never ends. In the non-terminating decimal expansion, we have our recurring non-terminating and non-recurring non-terminating, okay? Recurring means a particular number or a group of numbers a repeat, whereas in non-recurring, a particular number does not repeat or a group of numbers also don't repeat, okay? It just goes on and on. Now, why am I talking about these different types of decimal expansion? The reason is in our question, we have different types of fractions, right? And these fractions are rational numbers, okay? And these rational numbers can either be terminating or they can be recurring and non-terminating, okay? These non-recurring, non-terminating decimal expansions are irrational numbers, okay? So our decimal expansion can either be terminating or they could be a recurring but non-terminating, okay? They cannot be non-recurring and non-terminating because our numbers above in the question are fractions, and fractions are rational numbers, and rational numbers are either terminating or recurring non-terminating, okay? They can never be non-recurring and non-terminating because they are rational numbers, and only irrational numbers are non-terminating, non-recurring, okay? So let's see if our fractions are either terminating or a recurring non-terminating. So we have our first fraction as 36 by 100. Okay, so I have just copied our first question over here. Now 36 divided by 100 is 0.36, okay? This is a pretty simple division, but still I'll just explain it a little bit, okay? So if you have a number like this, then there is always point at the end of that particular number, okay? So you could also have a number like 10. There will always be a point at the end of that particular number, okay? We usually don't write that, but there is a point at the end. Now, whenever you are dividing a number by powers of 10, like 10, 100, 1000, 10,000, what happens is this point moves forward, okay? Now, how many times does that point move forward depends on the number of zeros that you have in the denominator, okay? So in our case, we have 2 zeros and our point is going to move 2 times forward, okay? So 1 time, 2 time, and then that point is going to reach over here. And our answer is going to be 36 by 100 is equal to 0.36, okay? And whenever there is a point in front, it's just a culture to write 0 in front of that point. And we get our answer 0.36, okay? So, for example, if we had something like 4796 divided by 1000, then we have our point at the end over here, right? And we have 3 zeros. So that point is going to move 3 times forward, okay? So 1, 2, and 3. And that point is going to reach over here, right? So our answer is going to be 4.796, okay? So that's how you divide a particular number by powers of 10. So in our particular case, we had 36 by 100. Our answer is 0.36. And we know that this is a terminating decimal expansion. And our first question is done. Now let's move to our second question. So our second question was 1 divided by 11. Now this is also a pretty simple question, right? So we just have to divide our 1 with our 11, right? I'm sure all of you know how to divide this, but still I'm going to explain it a little bit, okay? So first, we can't divide 1 with 11. And when these kind of cases arise, what we need to do is we need to put a point over here, right? When you put a point over here, what we can do is we can add 0 here, right? Now, can we divide this 10 by our 11? No, right? Then in that case, what we do is we put another 0 here, and then again, we can put a 0 over here, okay? So these are taught in smaller classes, but still I'm just explaining it a little bit, okay? Now, can we divide this 100 by 11? Yes, we can. We know that 11 times 9 is 99. And we just subtract this, we get 1, right? 100 minus 99 is 1. Now again, we have 11, right? And we need to divide our 1. Again, can we divide 1 with 11? No, so we can put a 0 here because of our point here, okay? And again, we are stuck, right? We can't divide this 10 by our 11. Now, to add another 0 over here, we need to put a 0 over here, okay? So without putting 0 here, we can't just keep on adding extra zeros again and again. You can add 1 0 with the help of that point, but if you need to add another 0, then you have to write 0 over here as well, okay? So now we have our 100, right? And again, we know that 11 times 9 is 99. And again, when we subtract this, we are going to get 1. So again, our process is going to repeat, right? Again, we need to put a 0 here to make 2 zeros over here. And again, we are going to do 11 times 9 is 99. So it keeps on repeating. So for this kind of case, what we can do is we just discuss that we can put a bar above the repeating numbers, right? So we get our answer 1 divided by 11 as 0.09 bar, which just means that this 09 keeps on repeating again and again, okay? Now, what type of decimal expansion is this? This is a recurring non-terminating decimal expansion, okay? So our 09 is recurring, repeating, but it's not terminating, okay? It's non-terminating decimal expansion. And that's our second question. Now, let's look at our third question. So our third question is 1 divided by 8. So we have our 1 divided by 8 here, but I just made a mistake while writing down the questions. It was actually 4, 1 divided by 8. It was a mixed fraction, but I forgot to copy that 4, okay? So we're going to be converting this 4 1 by 8 into decimal expansion instead of just 1 by 8, okay? So that we can learn how to convert the mixed fractions as well in the decimal expansions. Now, to convert this particular number in the decimal expansion, there are two ways, okay? So one of the way is first we convert this mixed fraction into improper fraction or normal fractions by multiplying this 8 with 4 and then adding the product with this 1, okay? So we get 8 times 4 is 32, 32 plus 1 is 33, divided by, in the denominator we'll still have 8, and then we divide this 33 by 8, okay? The other way to solve this particular question is we write that 4 as it is, and then we write plus, and then we have 1 by 8 over here, right? We write it like this. Then we convert this particular fraction into decimal expansion and then add it with 4, okay? And then we'll get the decimal expansion of this whole mixed fraction. For now, I'll just use this particular method instead of that one, okay? So we just divide this 33 with our 8. So we know that 8 times 4 is 32, and then we have 1 as our remainder, right? And then we can divide our 1 with our 8, so we need to put a point over here. And then we have our 0 over here. When we put a point over here, we can always add additional zeros in our remainders. So now we can divide this 10 with our 8. So we have 8 times 1 is 8. When you subtract this, you get 2. And then again, we can add 0 over here. And then we have 8 times 2 is 16. And when you subtract this, you are going to get 4. And again, we add our 0. And then we know that 8 times 5 is 40. And then our remainder is 0, right? So we have 33 divided by 8 is equal to 4.125. And this particular decimal expansion is terminating one, okay? Because it terminates. And our third question is also solved. If you want to do it in this way, you can do that as well. So we have our 4 plus. When you divide this 1 with our 8, you are going to get 0.125, okay? And then when you add these two numbers, again, you are going to get 4.125, okay? So you are going to get the same answer, and both of these answers are terminating, okay? So our third question is also solved. Now let's move to our fourth question. So our fourth question is 3 divided by 13. So this one is going to be pretty long, okay? So you need to know the tables of 13 to do this calculation. So we have our 3 over here. Now what we're going to do is we're going to put a point over here because we can't divide 3 by our 13. So we need to add our 0 over here. Now 13 times 2 is 26. When you subtract this, you're going to get 4. And since we have our point here, we can add a 0 here. And then we have 13 times 3 is 39. When you subtract this, you're going to get 1. Now again, we can put a 0 over here because we have our point here. And we can't divide this 10 by 13. Now to put an additional 0 over here, like I said before, you need to add a 0 over here as well, okay? You can only add a 1 0 with the help of this point. To add another 0, you need to write the 0 in our quotient as well, okay? So we have our 100 now. Now 13 times what is 100, right? So 13 times 7 is 91, okay? And when you subtract this, you're going to get 9. And again, we can add a 0 over here with the help of our point. Now 13 times what is close to 90, okay? So 13 times 7 is already 91. 13 times 6 is 78. And when you subtract this, you're going to get 12, okay? And then again, we can put a 0 over here. Now 13 times what is 120? So 13 times 9 is 117, okay? And when you subtract this, you're going to get 3. Now, again, we can add a 0 here, right? But we are not going to continue this division. Why? Because our remainder here is 30. And when we started this division in our question, we had also 30. So if you were to continue this process, again, you are going to get these same results, okay? So you would do 13 times 2 is 26, and then you would do 13 times 3 is 39, okay? So the whole process is going to repeat, right? And you'll be getting again, so 23079, and then again 23079, right? So it's going to repeat again and again. And whenever that happens, right, whenever we have a recurring decimal expansion, like I said before, we just put a bar above these repeating string of numbers, and that's our answer, okay? So the answer to our 3 divided by 13 is 0.230769, right? And we need to put a bar above here because it's recurring. And we know that this is a repeating non-terminating decimal expansion. So these numbers are going to continuously repeat again and again and again, and it never terminates, okay? So that's our 4th question. Now let's move to our 5th question. So our 5th question was 2 divided by 11. This one is pretty easy, okay? So we have already done a lot of divisions up to now, so I'm sure this will be easy for you as well. So we can't divide this 2 with our 11, so we need to put a point over here, and we get our 20, right? 11 times 1 is 11, and when we subtract this, we're going to get 9. You can put a 0 over here. 11 times 8 is 88, and again, when you subtract this, you are going to get 2. So if you add a 0 over here, our process is going to repeat because we have our 20 in our question, and our remainder is also 20. So again, it's going to be like 1 is 11, and again, it's going to be 8 is 88, right? So it's going to continue like this, okay? So we have our 1/8 repeating continuously, right? So we already have our answer, which is 0.18. And we need to put a bar above here because it keeps on repeating, okay? And we know that this is a recurring non-terminating decimal expansion. So it never terminates and it is repeating, okay? So that's our 5th question. Now we have our last question, which is 329 by 400, okay? So we're going to do this one a little bit differently, okay? So instead of dividing this 329 by 400, which is a pretty big number, what we're going to do is we're going to write this fraction as 329 divided by 4 times 1 divided by 100, okay? So this is going to give us 329 times 1 is 329, and 4 times 100 is 400, okay? So it's the same thing, okay? 329 by 400 is equal to 329 by 4 times 1 by 100. Now, when we do this, it becomes easier for us to do the division because we know the table of 4, okay? So first we'll just divide this particular number with 4, and then at the end we'll divide it by 100, okay? So we have 4, and then we need to divide this 329, right? Now we know that 4 times 8 is 32. When we subtract that, we get nothing, 0, right? And then this 9 comes down, so we have 9. And 4 times 2 is 8. Subtract again, so we have 1. Now we need to put a point over here, and then we can add a 0. So 4 times 2 is 8. Then we get 2, add another 0, and then we have 4 times 5 is 20, okay? And that's it. So we have 329 divided by 4 is 82.25, right? So we can write this 329 by 4 as 82.25. And then we can bring this 100 over to this side now. And we are going to get 82.25 divided by 100. And we just discussed in our first question that when we have 100 like this, what happens is this point moves forward 2 times, right? So 1 time and 2 time, and our answer is going to be 0.8225, right? And we need to put a 0 over here, okay? So we have 0.8225 as our answer to 329 divided by 400, okay? So again, we know that this particular number is a terminating decimal expansion. And done. We just solved our 6 questions. So if you had any confusions, let us know in the comments. And if you liked our video, give us a thumbs up and subscribe to our channel for future maths videos. Thank you.